Thank you very much for the introduction. It's quite hard to follow that now in English as someone from the West who is talking about quite a different topic altogether. So, yeah, but anyway, it was a very nice conversation before. I very much enjoy collaborating more and more with Asian colleagues. So, yeah, the more that we can do it, the better. Anyway, I'm here to talk to you about securely interacting with Bitcoin. And I am a researcher, so I come with a bit of a different perspective that maybe is normal at a conference like this. And when I was talking to my friend, I was trying to think, like, what am I going to say to these runes people? I can't tell them about research. I mean, I don't have any alpha to give you. I don't know how to make you rich. I don't know how to do slow things or expensive things like Bitcoin transactions. I don't care about those or hype or any of this kind of stuff. But I do think that you're great. Like, people who do innovation on Bitcoin, I think is absolutely amazing. And I really, really appreciate it. And I hope that people do it more and more. I love progress. I love the revolutions and the revolutionaries who do these things. So what can I do for you? The best thing that I can do as a researcher is tell you a bit about some research. I wanted to give you a bit of a view on how to kind of securely interact with Bitcoin, how to talk to Bitcoin generally. And so when people say DYOR, like, they kind of generally look at Twitter, maybe look at some influencers, listen to those people, but it's kind of a meaningless statement that has become a bit of a meme over the last few years. And so, like, many people say, oh yeah, how many transactions per second? What are the comparison websites? You see these Bitcoin layers and all these L2 comparisons. Like, these are great, but on the other hand, how much does it actually tell you about integrating or communicating with Bitcoin? Like, yeah, so they're good for one thing, but not for so many other things. And so if you want to think about security, and this is a topic of conversation that has come up multiple times throughout the day so far, now when we kind of move this innovation more towards Bitcoin and the economy has the potential to be so much bigger, security becomes much more of an issue, actually, and there's much more incentive to actually try to attack systems. So we really, really should be doing more of our own research. And so, as you know, with Bitcoin, like, if you get down to the real fundamentals of it, it's all about the keys and it's all about signatures. That is it. Like, apart from that, everything else is kind of fluff. So if you really want to do your own research on, like, what makes a great project or what makes something secure or least likely to rug you, look at how they do the keys and look at how they do signatures. This is like my small piece of alpha from a researcher. So if you want to look at, looking at keys and look at the signatures is a very easy thing to do, but, like, how do you actually do this? What are, like, good distributed signing systems? So one caveat here, one assumption that I'm making is that everything is in a distributed setting. I'm not talking about doing things off-chain. I'm not talking about doing things in a centralized way. If you're doing things in a centralized way, that's your own choice. Go do your own security there. But if you want decentralization, where you're removing a central point of trust and you have some expectations about security and decentralization, then these are the things you should look for. So one of the things is, the first thing to do, I said two things, keys and signatures. The first thing with keys is, how are they generated? Am I generating keys on the fly? First is, like, do I make them and pull them out of my pocket and then give them to you and then say, okay, secure it? This is not very secure. So any key generation should be done in a distributed way. If you are looking at a scheme, like if you're looking at any sort of Bitcoin layer 2 or any sort of Bitcoin signing scheme or any Bitcoin signing service, ask how the keys are generated. Are they distributed? Signing keys should never be whole. And they should also support key derivation. So if, like, a smart contract wants to be able to delegate control to somebody else, this should be supported. And then the next thing I said, okay, you have keys and then you have signatures. And then how is the signature generated done? Is this done in a centralized way? Well, then we're back to the centralized case where we can't really assume any security. So are they secure? Like, are there proofs of security? And maybe this seems kind of funny to say, like, are the signature schemes secure? Well, obviously, yes, they should be, but, like, can you actually show me proofs that these things are secure? This is not so common. Like, a lot of the blockchains that are making signature protocols and signing services do not have proofs of security, so you can't give real guarantees that security will be maintained. The other thing is that it should actually work. Like there should be some guaranteed output. If a smart contract calls for a signature, the signature should be delivered to the user at the end of the day. If something goes wrong along the way, does it break consensus? Does it break the blockchain? This shouldn't work. And so I think you see this with some other blockchains at the moment. Like if something goes wrong in the system, maybe if the system is overloaded, maybe if a few nodes go offline, consensus breaks and things stop. And then the chain goes down for a couple of hours and you can't trade and you can't do anything. This is bad. And like this is bad for your users, it's bad for your reputation, it's bad for everything. So I think like, I'll show you some protocols later, but I think like we are the literal only ones that do have this guarantee of liveness that like if something should go wrong in the signing protocol, it doesn't take the whole chain down with it. So this is something that I think nobody else can guarantee. Yeah, and shouldn't break the network. So this is the liveness property. This is like one of the kind of core innovations of some stuff that I'll show you. So something outside of the keys and the signatures, it should have network scalability. Like cryptography is kind of hard, it's computationally intense, so you should be able to do it on a system that is able to handle all of this. So what is the network communication model? Is it asynchronous? Is it partially synchronous? Do you have horizontal or vertical scaling or both? And yeah, if you really want to look at some metrics, look at transactions per second so that you know that this can generate some stuff. So this is my kind of view of like research for a minute. And I'll show you like, oh yeah, also peer pressure. Are all the above things, are they peer reviewed? Do other people agree that this is secure? Or are you just saying it and trust me, bro? And so always look like, are there some peer reviewed papers that can support things? So is all of this realistic? So I tell you like, you want nice keys, you want nice signatures. Can these actually be realized in the real world and like in a real system? And the answer is yes, we have done it, and they have been live for now 3 years this week. And so I give you a view of, sorry, the fonts are a bit messed up on the slides. So with ICP, there is the network, which is made of standardized node hardware running on independent data centers, and these are connected by the Internet Computer Protocol to form the network. So the network is there, it's been live for now 3 years. And this is the picture. So you see the gray boxes on the bottom represent the nodes, the purple layers in the middle represent the protocol, and these canister smart contracts sit on top of the protocol. This is the network, it's there, go use it. Instead of like rolling your own network and setting up everything from scratch and bootstrapping the whole thing and everything, like just setting it up in a secure way, here is a network that is there for you to use already. On the other hand, we have a huge research team and a lot of cryptographers. And we've done a lot of cryptography implementations. So one of the main things that we're kind of known for is this chain key cryptography. And this is distributed key generation and threshold cryptography, the signing that I mentioned before. And so this kind of key innovation allowed for like one single public key that sits on the Internet computer from which any computation on the Internet computer can be verified. So this is kind of the foundation of this verifiable Internet that I mean, some organizations are looking to build in the next 5 to 10 years. Here, it's already there. This is also the kind of alpha. It's ready, and it's been running already for years. So, yeah, this is the actual public key of the Internet computer. So any computation that comes from the Internet computer can be verified, so it's hard to forge or anything like this. So, yeah. We have the network, we have the crypto, and now the question is, how do we start extending Bitcoin? So ICP smart contracts can read, write, own, and program Bitcoin. How do they do this? So smart contracts on ICP can have their own ECDSA keys. So ECDSA is the signing algorithm of the Bitcoin blockchain. And so we saw the picture from before. We have the nodes on the bottom, the protocol layer in the middle, the smart contract sitting on top. The nodes collaborate together to produce a key, which then, your Bitcoin signing key, which then can sign a transaction and send it to the Bitcoin network. But if you know anything about signatures at all, you know that the ECDSA signatures that are used for Bitcoin are also used for Ethereum and other tokens like ERC20 tokens or USDC and things like this. So with this same key, you can also sign transactions not only on the Bitcoin network, but on Ethereum and other stable coins as well. And so, yeah, like I told you before that the smart contracts can generate the keys and hold keys, but how do they actually talk to the Bitcoin network? And so I bring you back to the picture again with the nodes sitting under the protocol, sitting under the smart contracts. So the ICP nodes are actually also running Bitcoin adapters on the nodes. So they always have access to the Bitcoin UTXO set and the Bitcoin state. So this is kind of like a very direct way to read and write to Bitcoin. And so there are kind of two core engineering novelties here. One is a Bitcoin API, so this allows canisters or smart contracts to get the balances, UTXOs, and send the transactions, direct communication. So this is kind of how we do it without bridges. There are no smart contracts here, no smart contracts there, but just a direct integration. And the other is this threshold ECDSA API, so this signing key generation and signature generation algorithms that allow smart contracts to hold an ECDSA key, so your Bitcoin signing key, and to actually generate signatures. And so these are the two kind of core things that you need to start building applications or L2s or whatever on Bitcoin. And so I started talking about doing your own research, and like a few of the community members have already done this. So there are a number of projects that are using this chain fusion tech, so these signing algorithms, to build their Bitcoin apps. And I think you've heard already from, well, one of them is this CKBTC. So this is a Bitcoin twin running on the internet computer. So as smart contracts can hold, read, and write Bitcoin, it's still subject to the Bitcoin base layer fees and settlement time. So we thought that it would be nice if we would create this sort of Bitcoin twin that would be able to leverage the kind of special properties of the ICP network. So having like 1.4 second finality and like marginal, like tiny fees for transfers. So this is CKBTC. This is one thing that runs, leverages the ICP network and one-to-one Bitcoin-backed coin. Another project is the Omnity network, who I think you heard from already today and who you'll hear a little bit more from throughout, the year. I think they have like some huge, like really a lot of plans, and I think they've taken CKBTC that I've showed you before and built like a whole lot of stuff around it. And like I hope you've played around with the Runes bot that they have in Telegram. It's like the absolute coolest way that I have seen anybody do runes so far. And like the two of us over lunch were like there going, like trying to figure out the best ways to play around with this. So Omnity, I think, is one of the best protocols actually building on ICP at the moment. Another is Bionic, which is an ordinals marketplace. So this has been running also for, I guess, over a year now. So this is also, they claim to be the world's fastest Bitcoin ordinals marketplace. And it allows to send, receive, and scribe ordinals and this kind of stuff as well. So these are two of the kind of core, I think, Bitcoin meta protocol apps building on ICP at the moment. And so that's it from me. I hope you enjoy. If you have questions, I'm happy to talk. Security, I hope you learned something. But feel free to look at the documentation, and thank you very much.